Hello students, welcome to Trunkie Academy. I am Dr. Pallavi Kulkarni, your chemistry teacher. Today we are going to learn one name reaction from organic chemistry from the chapter hydrocarbons. Let us learn that reaction today. Okay, so this topic which we are going to discuss, it belongs to the chapter hydrocarbons. The name of this reaction which we are going to discuss is the Wurtz reaction. Okay, name of the reaction is Wurtz reaction. So first of all, let me just tell you, this is a named reaction. Why this is called as named reaction? Because the reaction which are named by the scientist who invented the reaction, such a reactions are called as named reaction, right? So Wurtz reaction is such a such a type of the chemical reaction, right? First of all, let us see the general reaction. Okay, let us see the general chemical reaction for this Wurtz reaction. So in this Wurtz reaction, we are going to treat the alkyl halides. Usually alkyl bromide is taken, RX I will take. It is treated with sodium metal. Okay, 2 molecules of alkyl halides are taken. So I will write down one molecule here and another molecule here. Okay, yes, and then this reaction, yes, this reaction is carried out in the dry atmosphere. I'll explain why this is carried out at dry atmosphere later on when we are going to discuss its mechanism. So dry ether is taken. So this reaction, to write down the product of this reaction is really very easy to do thing. How? Let us see. So what you have to do, simply you have to delete this part. Okay, 2x, that is halogen atoms from the alkyl halides, and 2 sodium atoms you are going to remove, right? So this is how there will be a byproduct which is nothing but NaX, 2 molecules of NaX, that is sodium halide we will be getting, and simply you have to join the 2 R to each other. R is nothing but the alkyl group, right? R is nothing but the alkyl group, right? So this is how we are getting the product of this reaction. Sodium halide is a byproduct or side product, whereas R attached to R, which is nothing but the higher alkane. Okay, which is nothing but the higher alkane. Okay, is the higher alkane than the starting material. Okay, so this is the product of this reaction. So what we are taking here, we are taking the alkyl halide molecules, 2 alkyl halide molecules we are taking, we are treating it with the sodium metal, right? Okay, so this is nothing but the Wurtz reaction. Okay, this is nothing but the Wurtz reaction. Now how to write down the products of the Wurtz reaction, we are going to discuss by using this. So first example I am going to discuss with you. Okay, first example is, if R is the smallest alkyl group, that is CH3, and if X is Br. Okay, and if it is treated with Na, okay, 2 molecules of alkyl halide we are taking, and this reaction is carried out in the dry atmosphere, that is by using the dry ether as a solvent. Okay, so how to dry the solvent, that also I have told you. That is the solvents, organic solvents, ether is the organic solvent, so they are redistilled, that is distillation is carried out again and again, so that we are removing the moisture completely. Similarly, they are passed through dehydrating agents also. So these dry solvents do not contain a single drop of water molecule, right? Okay, so NaBr, sodium bromide, is the byproduct, right? What is the byproduct name? Sodium bromide. Okay, what will be the product then? 2 R you have to connect to each other, that is CH3 connected to CH3, CH3 connected to CH3, that means C2H6. Okay, that means an alkane containing 2 carbon atom. Name of this alkane is ethane, right? Name of this alkane is ethane. So when you are treating the methyl bromide, 2 methyl bromide molecules with each other, we are getting the ethane molecule, right? So you can see the number of carbon atom is doubled, right? Number of carbon atom from starting material to reactant is double. Methyl bromide contains only one carbon atom. Ethane product contains two carbon atoms, right? Okay, yes. So now just take a screenshot of this general reaction first of all, and then we will see the next mechanism of this reaction, and then again some examples. Okay, now let us see the mechanism of this Woods reaction in detail. So mechanism can be explained with the radical mechanism as well as with the ionic mechanism. I will first of all explain with the help of radical mechanism. Okay, so we are going to see first of all the radical mechanism. Radical mechanism means what? The mechanism in which free radical is generated. Okay, radical mechanism. So what we are using here? So we are using sodium metal, right? Sodium is a metal. Sodium has 11 electrons in it. Electron configuration of sodium atom is 1s2, 2s2, 2p6, 3s1, right? Okay, so sodium has a tendency to lose electron, right? Sodium has a tendency to lose electron. So what happens here? The sodium metal, it will lose its one electron, that single electron, to the another atom. Okay, and it will get converted into sodium radical, right? It will get converted into sodium radical. Okay, so one sodium atom will give its one electron to the another sodium atom, and it will give its sodium radical, right? Okay, so for an example, the another sodium atom I'll write down. So there will be formation of Na dot. Dot on Na means it is a sodium radical, sodium free radical. Okay, free radicals are also the one type of reactive intermediate, just like carbocation and carbanion are. Okay, yes, so they also take part, they are also involved in the during the mechanism of any reaction, right? Okay, yes, just like here the free radicals are generated. Okay, so this generated free radical, that is sodium free radical, it will react with the this one alkyl halide. Okay, we'll take the example of here. Okay, for the mechanism we'll take the example of reaction of CH3CH2Br. Okay, reaction of CH3CH2Br, that is ethyl bromide treated with two sodium metals, CH3CH2Br, that is ethyl bromide. Okay, so there will be loss of the reaction carried out in the presence of dry solvent ether. There will be loss of two sodium bromide molecules, and the product will be CH3 CH2 CH2 CH3. Okay, now this should be written in a line, but as I do not have space here, I should have written the reaction previously, but yeah, now I am writing it. Okay, so this is the reaction. So the ethyl bromide molecule I'll write down the ethyl bromide molecule in this way. Okay, so it is CH3 CH2Br, that is nothing but ethyl bromide molecule. So what is going to happen? Sodium radical is going to react with this ethyl bromide molecule. Okay, sodium radical is going to react with, so radical reaction takes place. Radical reaction means homolysis, right? Homolysis means like this. Okay, there are two electrons in this bond, right? Single line two electron. Out of two, one will be combining with the sodium electron and one will transfer on the carbon atom. Okay, yes, so there will be a loss of NaBr, right? Na radical and Br radical combines to form NaBr, and this CH2 will carry the radical now, right? So there will be formation of CH3CH2 radical, which is called as ethyl free radical, right? So this is how from sodium the ethyl free radical is produced, right? Okay, now this ethyl free radical is going to react further. How? Yes, so this ethyl free radical is going to react in two ways. Okay, so first way is called as dimerization. Ethyl free radical, yes, I'll write down here, ethyl free radical undergoes following two reactions. Ethyl free radical undergoes following two reactions. First of all, dimerization. Okay, first of all, dimerization. Okay, yes, dimerization means dimer formation. Okay, yes, let us see how the dimer formation takes place. Yes, if you have any doubts in between, please let me know in the chat box. Okay, let us see dimer formation. So what happens? One ethyl free radical, which I will write down like this, it will undergo dimerization with the another ethyl free radical, right? So these are the two ethyl free radical, they will undergo the dimerization, right? Okay, dimerization means these two radical will form a chemical bond. One radical means one dot means one electron, right? So two electron combining means there is going to form a chemical bond in between these two carbon atoms, right? Okay, and what we are getting then? So CH3 CH2 CH2 CH3, right? And which is nothing but N-butane, right? Which is nothing but N-butane. Okay, so by dimerization what we are getting? N-butane. Okay, then the second type of reaction which it can undergo, this N-butane can be called as a major product. There is a maximum probability of dimerization. Therefore, here usually we write down the product like this. Okay, after dimerization, product we write down. But apart from that, the two more products are also produced. Okay, which I am going to explain right now. These two more products which I am going to write down, they are not written usually because they are not formed. They are not the major products, right? That's why they are not written. But how they are formed? They are formed by the reaction called as disproportionation. They are formed by the reaction called as disproportionation. Okay, disproportionation reaction. Okay, what is disproportionation reaction? Let us see. So for that purpose, I will write down the structure of ethyl free radical like this first of all. So this is the one ethyl free radical. Okay, yes. So what will happen first of all? Okay, it will combine with the other ethyl or other radical. That other radical I will write down like this. Instead of CH3 CH2, the one hydrogen I will write down like this. Okay, yes. So they are going to combine with each other. How? They are not going to undergo dimerization but a different type of reaction. What? Let us see. So what happens? Here there are two electrons, right, in between these two bonds. So out of, yes, so this I will just show up like this. Okay, so there are two electrons here in this bond. Out of two, one is transferred on this carbon and other is transferred to form a bond with this, right? That means this hydrogen will take its single electron and it will form a bond with this carbon atom. Do you understand? So there will be a formation of bond in between this hydrogen and this CH2. Okay, so let us see what will be the product then. So CH3 and CH2 will form a bond with one more hydrogen. So it will become CH3, right? So ethane is one product. Okay, ethane is one product. Apart from ethane, the another species which is produced, this one. Let us see what is that. So you can see one electron is with the hydrogen, but what about the other electron? It resides on that carbon, right? Okay, so that also I will write down. So there will be single electrons on both the carbon atoms now, right? So this is how we have obtained a di-radical. Di stands for two radical, that is single electrons are present on the carbon atom. So this di-radical is produced. Okay, now what happens to this di-radical further? It is going to form a bond with each other like this, right? So already there was a single bond present in between these two. Now there will be formation of a double bond, right? So this is how we are getting this as another product, and that is nothing but ethene. Okay, that is nothing but ethene. So you can see this in this reaction, in this disproportionation reaction, no any new species is generated. Just here only, just here only the molecule is rearranged somewhat. Here also molecule is rearranged somewhat, and we are getting ethane and ethene, right? No any new thing is generated. Therefore this is called as disproportionation reaction. And one more thing, during this reaction the oxidation states are interconverted or they are changed, right? Therefore this is called as disproportionation reaction. Now by disproportionation we are getting this ethane and ethene, which are the minor products, which are not major products, they are minor, that is produced in the small amount, right? So this is the mechanism for the Wurtz reaction for the example of ethyl bromide. Okay, I hope you understand. So usually we write down only this as the product because this is a major. We do not write down those minor products because they are produced in less number. So just take a screenshot of this mechanism first of all. Okay, now this was the mechanism for Wurtz reaction. Now, there are few drawbacks of this Wurtz reaction that I am going to tell you. There are 3 drawbacks of Wurtz reaction. Okay, out of which first drawback is we cannot produce methane by using this reaction. Okay, methane cannot be produced. Why? Because in methane there is only one carbon atom. In the Wurtz reaction, the carbon atoms are doubled, right? So there is no any alkane which contain half carbon atom, right? Therefore we cannot produce methane by this reaction. Second drawback, if we are carrying out the cross Wurtz reaction, right? Cross Wurtz reaction, then it gives a mixture of product. Okay, mixture of products, and that mixture of products is difficult to separate. Mixture of products which is difficult to separate. Okay, which is difficult to separate. What is the meaning of it? I'll explain. Let us take a simple example, okay, of cross Wurtz reaction. Okay, now due to this also we cannot produce odd number of alkanes also. Hence it is difficult to produce alkanes containing odd number of alkanes with odd number of carbon atoms, right? Even number is possible, but odd number is difficult. Odd number of carbon atoms. Okay, why this is so? Let us see. Okay, so let us see. So here I'll take the example. Like for example, if I am trying to prepare the propane which contains 3 carbon atoms. So for propane, I should take 1 methyl bromide, 2 sodium atoms, and I should take another ethyl bromide, right? So 2 plus 1 will be 3 carbon atom. That is desired thing, right? Okay, but here we are getting the different products. Okay, what are these different products? Let us see. So first of all, what happens? Okay, let us see. The desired product is obtained. What is that? That is CH3 will combine with CH2CH3. Okay, that is fine. That is one product, which is the propane. Okay, but apart from that, it will give you the unwanted products also, right? For example, methane can combine with this can combine CH3Br can combine with CH3Br, another molecule of CH3Br also. So we will get CH3CH3, right? CH3CH3 stands for ethane, right? This may be another product, or one more product can be produced. That is this can combine with the ethyl bromide can combine with another molecule of ethyl bromide, and it will give you CH3 CH2 CH2 CH3, which is nothing but butane, right? So we will get a mixture of these different alkanes here, right? And as we know, they are having the similar boiling points. Okay, they are having the similar boiling points, and similarly the alkanes are really very unreactive in nature. Therefore it is difficult to separate this mixture, right? For example, I am able to produce this propane from this, but what about separation? I will not be able to separate this from the mixture because their boiling points are very very near to each other, so I cannot carry out distillation. You understand? This is called as cross reaction. Reaction between different molecules means cross reaction. Okay, then third drawback I will write down after this. That is, if we are trying the reaction with the tertiary alkyl halide. Okay, tertiary alkyl halides don't give Wurtz reaction. Okay, then what they give when treated with sodium and this dry ether? They give elimination reaction, elimination reaction, elimination reaction to form an alkene, to form an alkene as the product. Okay, instead of Wurtz reaction, what they give the elimination reaction. Okay, tertiary alkyl halide. Okay, yes. So example of tertiary alkyl halide I'll write down. Tertiary alkyl halides mean in which halide is attached to tertiary carbon atom. Okay, this is a tertiary carbon atom if bromine is attached to it. Two such molecules of tertiary butyl bromide. Okay, tertiary butyl bromide, if treated with sodium metal in the presence of dry ether, instead of the alkane formation, that is two carbon connection, instead of that we are getting two products. One is the product of elimination, right? One hydrogen from here and bromine from here will be lost, and we'll get this one, which is called as isobutylene. And another product is simple alkane, CH3C, CH3, HCH3, which is nothing but isobutane. Okay, so this is how, these are the three drawbacks of Wurtz reaction. First, it cannot produce, methane cannot be produced. Second, we cannot produce the odd number carbon atom containing alkanes. And third, tertiary alkyl halide cannot react, give the Wurtz reaction. Okay, yes. Now take a screenshot of this page also. I hope you have taken a screenshot. So that's all about the Wurtz reaction. So before ending the class, let me just show you about DPP, daily practice problem. Yes, so this is a teacher's portal, similar is yours. Go to the resources, then go to all the way down here in the writing material. Then you can see DPP over here. Just click on DPP, daily practice problem. You will be able to download it also. Write down the solutions on your notebook or any paper. Take a picture of it and just upload it on the portal, your portal, so that teacher will be able to see it. Okay, yes. So then teacher will evaluate it and let you know the suggestions wherever required. Okay, I hope it is clear to you. So that's all for today. Thank you so much, students, for joining. Thank you so much for your precious time. All the best to you and take care.